Hello, welcome everybody. Welcome to my YouTube channel Aditya Maurya. My name is Aditya Maurya and I'm currently pursuing BE in Sri Venkateswara College of Engineering, Bengaluru. My library number is 23CA 1736 and I'm currently studying the first semester, the section Devo. Today we'll be discussing a small topic in physics. So the course code is BPHYS102 and the title of the course is Applied Physics for CSC stream. The topic that I've chosen today is Heisenberg's uncertainty principle and also its physical significance. So let's dive into this and let's have a better and clear understanding of this topic. Okay, so in everyday life, calculating the speed and position. The speed and the position of a moving object is relatively straightforward. Calculating the speed and position of a moving object is clearly and relatively straightforward. We can measure a car traveling at 60 miles per hour or a tortoise crawling at 0.5 miles per hour and simultaneously pinpoint where the objects are located. We can simultaneously pinpoint the location of the object. But, but, sorry for that. In the quantum world of particles, making these calculations is not possible due to the fundamental mathematical relationship. Due to the fundamental mathematical relationship called the uncertainty principle. The uncertainty principle. So what is Heisenberg's uncertainty principle? Heisenberg's uncertainty principle states that it is impossible to measure or calculate exactly both the position and the momentum, of an object. This principle is based on particle duality of matter. This principle is based on the particle duality of the matter. Although Heisenberg's uncertainty principle can be ignored in the macroscopic world, emphasize here macroscopic world, not in the microscopic world. It holds a significant value in the quantum world, since atoms and subatomic particles have very small masses and any increase in the accuracy of the position will be accompanied by increase in the uncertainty associated with their velocities. If there's any certain increase in the accuracy, it will be accompanied by also the change in the position of the particle or the object. So we come to a equation. We get an equation where we write delta p dot delta x. Delta p dot delta x or delta p into delta x is more than or equal to h by 4 pi, where delta p is the momentum and delta x is the position of the particle. We get this equation for the Heisenberg's uncertainty principle for the position and the momentum of a certain particle. But we also have some other forms of this thing, that is delta E into delta E. I mean delta T into delta E is more than or equal to h by 4 pi. There are many other forms, but I've just taken these two forms to understand here, to discuss here. That is these two, delta T dot delta E and delta P dot delta X. Let's have a better understanding of the Heisenberg's uncertainty principle using this roller coaster image. As you can see on the left side, when the roller coaster reaches the peak, of the hill, we could take a snapshot and know its location. But emphasize here that the snapshot alone would not give us enough information about its speed. So what you can do here is you can just get to know the position and not the speed, because when you take a photo of it or a picture of it, you just get to know the location of this thing and not the speed or any other information that is required. When you come to the right one, let's get to the right one. As the roller coaster car descends the hill, we can measure its speed over time but would be less certain about its position. The left side, we saw that we could get the position and not the speed because it was stationary and it was standing at the particular position because we took a picture of it. We took a picture of it so we could get to know that this is the position, but we did not get the speed of it. But when we come to the right side, we see that this is moving. This is driving, this is moving, and we can now get to know the speed of it but not the position of it because it is moving and it's variable now. The position will be variable, it will keep changing with the time, and also the speed. It's crazy fast, I don't know, this is crazy fast, this will go fast, and we will not be able to analyze the position of it. Okay, so that was all about Heisenberg's uncertainty principle. So now let's get to the physical, the other part of the topic, physical importance of Heisenberg's uncertainty principle. So the physical significance of Heisenberg's uncertainty principle. The physical significance of the above arguments is that one should not think of the exact position or an accurate value for a momentum of a particle. One should not think of the exact position. We cannot think about the exact position, also the accurate value for the momentum of a particle. We either get the position or the momentum. Instead, one should think of the probability of finding the particle at a certain position. Instead, what we can do is think of finding the probability. We can get the probable data, we can get the probable position or the speed of the particle. We cannot get the exact. The estimation of such possibilities are made by means of certain mathematical functions named probability density functions in quantum mechanics. This is the name, it's long. Probability density functions in quantum mechanics. Similar interpretation is made for the conjugate pair delta E dot delta T. As we did see here, that this is the other form of delta, this is the other form of Heisenberg. We get to know that this belongs here. This belongs here. Okay, so that was all about today's topic. I hope you understand and enjoy the topic, and I hope you like and maybe comment on this video and let me know or the criticism that is welcomed in this video. Thank you.